Welcome back. We are still on Unit 11, Day 3. We're going to finish up geometric probability with example number 5. Your mom's minivan has a 24-gallon tank. What is the probability that when the engine is turned on, the needle on the gas gauge is pointing between 1/4 and 1/2 full? So let's think about what the gas gauge might look like on your car. Everybody's car is a little bit different, but let's say it looks something like this, right? And you've got your E on one side for empty, excruciatingly empty, and fabulously full. Okay, and then you have your halfway mark when your gas tank is halfway full. And then usually there'll be quarter marks here and here. So here you're 1/4 full, here you're 3/4 full, and some tanks will also mark your 1/8. Okay, every gas tank again is a little bit different. But this is wanting to know what is the probability that I will land between 1/4 and 1/2. So I am trying to fall between here and here for my gauge. Okay, so what is the probability that I will land in here? Okay, well, if I divide this into equal fourths, right, 1/4 here, 1/4 here, 1/4 here, and 1/4 here, I am looking to land in this section, right? So the probability that I land between 1/4 and 1/2 is I'm looking at one section out of 4 sections. So 1/4, and now that's not going to reduce, right? Because it's already reduced. 1/4 times 100 is 25%. So 25% of the time you randomly check the gas tank on your vehicle, it should fall between 1/4 and 1/2. Okay, let's look at number 6, 7, and 8. Number 6, use the spinner to find each probability. If the spinner lands on a line, it is spun again. Okay, so it's definitely not going to land on a line. It's going to land in an actual spot. So my first question is, what is the probability that we will land on red? So if I look at red, I can see there's a 40 and then a degree symbol. So there's 40 degrees. This is really important to note that it is degrees because you need to think about if there's 40 degrees in this wedge, 40 degrees out of how many total around, right? Around the circle, there's 360. Not all circles give you the same data. So sometimes you'll need to look because they might have this broken down into, maybe they surveyed some people and they said, what's your favorite color? And 40 people said they chose red, and a different number said they chose yellow, and chose blue, and chose green, and chose orange. And so you'll need to add up, or you'll need to know how many people were surveyed to know what the total number is. Sometimes you'll see percentages in each one of these. Those percentages are going to be out of 100 because it's going to be the whole circle, 100% of the circle. But when you're looking at degrees, think about how many degrees around the whole circle. So that's why underneath I put 360. So you really do need to pay attention to the units anytime you're working with circle sectors and probability, because degrees versus percentages versus numbers of people or numbers of items are going to really affect what your number that's total down here is going to be. Anytime it's degrees, your number here will be 360. Anytime it's percentages, your number here would be 100. And then if it's some other value, then you need to know the total number of people or objects that were looked at in creating the pie chart. Okay, all right, so let's reduce this fraction. 40 divided by 360. Reduce that fraction for me, 1/9. And then as a decimal, math, give me a decimal, times 100. Oops, I think I forgot to hit enter. Let's just try it. 1/9 as a decimal, and then times 100. And we get 11.1%. for the probability that we land on red. Let's look at the probability that we land on blue. The probability that I'm going to land on blue, here is blue, and always check your spinner to see if there's any spaces that are the same color, like if a color repeats. I can see on this one all my sections are different colors, so I don't have to worry about that, but sometimes you'll have a spinner that repeats colors, so you have to really watch for that. But this is not, it's 30 out of 360. So 30 out of 360 is, oops, math, give it to me as a fraction, is 1/12. And then as a decimal, times 100 gives me 8.3% for my probability of landing in the blue section. And then the last one here, number 8, the probability that I land in purple. The probability of landing in purple is going to be, now notice I don't have a number for purple. So to get this purple, I need to know how many degrees are here. But I do have all the other degrees, right? I know I've got 40 red, I've got 110 yellow, I've got 30 blue, I've got 80 green, and I've got 70 orange. So how much do we already have? 40 plus 110 plus 30 plus 80 plus 70. I've already used 330 degrees, which leaves me out of my total 360 degrees, that's going to leave me with 30 degrees, right? 360 minus 330 leaves me with 30 degrees. So I know the purple is 30 degrees, which makes sense because look at this purple angle and look at the blue angle. They're vertical angles of each other because I have a straight line here. I have a diameter here and I have a diameter here. So those are vertical angles, which means they have to be equal to each other. Okay, again, remember that only works if you have diameters that intersect each other. So I know it's going to be 30 out of 360, which if you look at number 7, we've already done because they're the same. It's going to be 1/12 or 8.3% is the probability of landing on purple. Okay, hopefully that helps looking at geometric probability. If you still have any questions, please make sure you're asking your teacher during class time, and I will see you in the next video. Thanks so much for watching.